Hello, in today's video we're going to be covering section 6.5, day 2 of solving exponential equations. In our previous video we talked about solving exponential equations where the left and the right side have the same base. Go ahead and take a minute, pause the video, and practice these 6 on your own. So as we talked about in our last video, if the bases are the same, then the exponents must be equal. The only number that can go in the x spot here so that the left and the right sides are the same is a 2, which means that x has to equal 2. Here the bases are the same. I have a 12 and a 12, which means the exponents must be the same, so there must be a 5 here in order to make the left and the right hand sides the same, which means that x has to equal 5. Similarly, 14 and 14 are the same base, so 3 and x have to be the same, so x would equal 3. Here my bases are the same, which means my exponents must be the same, so 4 and x have to be the same, or x is equal to 4. Here, since the 6's are the same base, my exponents must be the same, so x would have to be 8. And negative 2 is my base on the left and on the right, which means that in order for the left and the right side to be the same, my x would have to be a 7. If you made any mistakes, go ahead and pause the video so you can go back and correct any errors. Go ahead and take a minute, pause the video, and practice these 3 on your own. Here we have a very similar strategy. The bases are the same, which means the exponents must be the same. But once we set up that equation, we're not done. I know that the exponents must be equal. 2x would have to equal 6 then. But once I set up that equation, I now need to solve. So I go ahead and I divide both sides by 2 to get x has to equal 3. So if we were to go back and check our answer, 2 to the power of 2x is equal to 2 to the power of 6. 2 to the power of 2 times our number is equal to 2 to the power of 6. And we are saying that that number, x, is a 3. So 2 to the power of, when I multiply the 2 and the 3 together, I get 6 is equal to 2 to the power of 6. And sure enough, the left and the right hand sides are the same. In number 2, the exponents must be equal because both bases are 5, so 2x has to equal x plus 1. And we solve by subtracting 1 from both sides. So 2x minus x is just 1x is equal to positive 1. On the left and the right, I have a base of 7, which means that the exponents must be the same. So 3x plus 5 and x plus 1 must be equal. I go ahead and I solve. First, I'll get my x's together. 3x's take away 1x is going to be 2x plus 5 is equal to 1. Subtract our 5 from both sides. So 2x is equal to negative 4. And then divide both sides by 2, so x is equal to negative 2. Again, if there are any mistakes that you need to go back and correct, please take the time to pause the video and go find and fix those mistakes now. Solving exponential equations with unlike bases. So in example A here, I have x in an exponent. On the left, the base is the number 5. So on the right, what I need is 5 to some power. But that's not what we have. What we have instead is the number 125. So what we do is we say, I want to find a way to rewrite the number 125 as the number 5 to some power. Well, one thing we know about the number 125 is that it's actually 5 times 5 times 5. On a calculator, if we go ahead and pull that up, 5 times 5 times 5 equals 125. So another way to say that is that 125 is 5 to the power of 3. And now we can use the strategy that we used on the first few slides. Because the bases are the same, I have a base of 5 and a base of 5. That means that these exponents have to be equal. So x would have to equal 3. In B, we have a very similar question. I have 4 to the power of x is equal to 2 to the power of x minus 3. But the problem is that the 2 and the 4 are not the same base. So what we want to do is break them down so that they do have the same base. The 2 cannot break down any farther. So I look at the 4. The 4 can be rewritten as something to the power of x with a base of 2. I want a base of 2 because on the right side I have a base of 2. 4 is 2 times 2, or 2 squared. Now that I have it as a base of 2, I simplify my exponents. An exponent on an exponent means we multiply. 2 times x, so here I have 2 times x equals 2 to the power of x minus 3. Now I have manipulated the left and the right so that the bases are the same. The bases are both 2. Because of that, I can take my exponents and set them equal to each other. I solve by subtracting x from both sides. 2x minus x is equal to negative 3. In C, I have 9 to the power of x plus 2 is equal to 27 to the power of x. I'm going to break these both down. I know that 9 is actually 3 times 3. That's helpful because I can rewrite it, instead of 3 times 3, I can rewrite it as 3 to the power of 2. We broke it down as far as it goes. 3 will not factor anymore. So on that left-hand side, I multiply my exponents. So this is 3 to the power of 2 times x plus 2. Or 3, I distribute my 2 to get the power of 2x plus 4. So I broke down the left side as far as it goes. On the right side, I'm going to break it down again as far as it goes. 27 is 3 times 3 times 3. Because it breaks down into a bunch of 3's, I can write it as a power, 3 to the 3rd power. And again, since I have an exponent on an exponent, I can multiply to get the power of 3x. So on the right-hand side, I have 3 to the power of 3x. I have a base of 3 on the left and on the right. Because my bases are the same, I can set my exponents equal to each other. So 2x plus 4 must equal 3x. I'll get my x's together. I think it makes the most sense to move my 2x over. That way I move it away from the 4. So 4 is equal to 1x, or x is equal to 4. So we broke down both the 9 and the 27. The 9 we rewrote as 3 squared, and the 27 we rewrote as 3 to the 3rd. Once we did that, we got to this line here where we have the base of 3 on the left and the right-hand side, and then we're able to set the exponents equal to each other and solve. Go ahead and take a minute, pause the video, and try these 3 on your own. For number 4, we have a base of 4, and we're raising it to the power of x. If we can rewrite 256 as 4 to some power, then we don't need to break down the 4 anymore. So let's test it out. 256 can be rewritten as, if I'm factoring, 4 times, when I divide 256 by 4, I get 64. And then I'm going to divide by 4 again, and I get 16. Then I divide by 4 again, and I get 4. So what we found is that 256 actually equals 4 times 4 times 4 times 4. So on the right-hand side, I broke it down into a bunch of 4s. On the left-hand side, I still have 4x. So rewriting it as an exponent, 256 can be written as 4 to the power of 4. And now that we have the same base on the left and the right, we know that the exponents must be equal. So x has to be 4. And again, the only number that we can put in this x spot is a 4. That's the only way to make the left and the right sides equal. In number 5, the bases are different. I have a 9 and I have a 3. Now the 9 I can break down as a factor of 3. 9 is 3 times 3. So instead of writing 9 to the power of 2x, what I can write instead is 3 squared to the power of 2x equals 3 to the power of x minus 6. So I didn't change the problem, I just changed the way it looks. 9 is 3 squared. So this is the same problem that we started with. To simplify, exponent on an exponent means we multiply. So 3 to the power of 2 times 2x is equal to 3 to the power of x minus 6. 3 to the power of 4x equals 3 to the power of x minus 6. Now that the bases are the same, we go ahead and we set our exponents equal. 4x has to equal x minus 6. Subtract our x from both sides. So 3x is equal to negative 6. And then we divide both sides by 3. So x is equal to negative 2. In number 6, if I try to factor down my 8, I will not be able to write it as a power of 4. 8 is 4 times 2. So I'm not able to write this as a power of 4, which means I need to keep breaking it down, and I will need to break down the right side as well. So instead of writing the number 8, I see that it breaks down into 2 times 2 times 2. So 8 can be rewritten as 2 to the power of 3. So now on the left, let's look at the 4 and see if we can break that down into a power of 2. Sure enough, 4 is 2 times 2, or 2 squared. An exponent on an exponent means we multiply, so 2 to the power of 2 times 3x, and then 2 to the power of 3 times x plus 1. I multiply to get 2 to the power of 6x equals 2 to the power of, I distribute to get 3x plus 3. The bases are the same. I have 2 on the left and a base of 2 on the right. So I set my exponents equal. They must be equal. And I get the equation 6x equals 3x plus 3. Subtract our 3x from both sides. So positive 3x is equal to 3, and then divide by 3. So x is equal to 1. This is where we're going to go ahead and wrap up our video for today. Thanks so much for watching, and have a great rest of your day.